We are going to start right now. So we will start with Karin. We will show some voice AI. Let's get started.
Okay, so my name is Karin Bergling. I work at the RRI, and we are going to kickstart this 45-minute-long hands-on demonstration by stepping into the novel world of AI voice agents. So voice agents are artificial intelligence that is trained to hold conversations with humans. And in the future, this may serve very well in healthcare to relieve administrative burden and also to serve as a bridge between patients and healthcare clinicians. We are going to start with a demonstration where I am going to be a patient in my home, and an AI agent called Anna is going to call me, and we're going to have a conversation. Before we start, so Anna, she is really good at ignoring background noises. However, she is an expert in picking up any type of human speech. That is her job. So when we do the demonstrations, please keep all side conversations to a minimum.
Hello, this is Anna, an AI secretary calling from the Renal clinic. May I speak with Karin Bergling, please?
This is she. I'm Karin.
Thank you for confirming, Karin. I'm calling because you were recently admitted to the hospital with acute kidney failure, and I see you've got a follow-up with Dr. Wang in about 2 weeks. I'd like to ask a few quick questions before that. Do you have a few minutes to talk?
Anna, could you just give me 1 minute? I'm doing a demo, so I just need a minute.
Of course, that's okay. Take your time. I'll wait here.
Okay, now. I'm ready for you now, Anna.
Great, thanks. Just to make sure I've got the right Karin, could you please tell me your home address and zip code?
My address is 315 East 62nd Street, and my zip code is 10065.
Perfect, thanks, Ms. Bergling. How have you been since leaving the hospital?
I've been good. Thank you so much for asking. I'm still feeling kind of tired, but I'm feeling much, much better compared to before I was admitted to hospital. It was horrible.
I'm really glad you're feeling better. About your meds, were you able to pick up the new prescriptions, and are you taking them okay? Any questions or anything not clear?
No, it was totally fine to pick up the medications. However, Anna, I did miss to tell you something. Over the past few days, my legs have started to swell up. It's really weird. They're like elephant feet. I can't wear anything but Birkenstock.
Thanks for telling me that, Karin. Could you tell me a bit more about what you've noticed with your legs? Like how this has been for you over the past few days?
It started a few days after I went into the hospital, and it wasn't that bad at first, but over the past 3 days, it's been really bad. The legs are huge.
Karin, that does sound like you need medical attention. I'm not a nurse, so I can't give medical advice. But I can have a renal clinic nurse call you shortly. Would you like me to arrange that now? And if your symptoms feel really bad, like sudden shortness of breath, chest pain, or the swelling is rapidly worsening, please call 911 right away.
It would be great if you could have one of the nurses call me. I've been thinking if I should call, but I decided it's probably not that bad. But please set up a call.
Absolutely. I'll notify a renal clinic nurse to call you shortly. If no one reaches you within the next hour, or if the swelling worsens, you feel short of breath, chest pain, or anything suddenly gets worse, please contact urgent care or 911 right away. Before I hang up, is this the best number for the nurse to reach you?
Yes, you can call on this number.
Got it. Please keep your phone nearby. The nurse will call you shortly. If you miss it, they'll try again. Take care, Karin.
Okay, thank you so much, Anna.
Okay. I am happy that Anna threw in 2 call 911 disclaimers if the symptoms get worse. That is promising. We were thinking of doing one more demo, and we would like a volunteer from the audience to take the leap into this world of AI agents. Are there any volunteers? I saw Bill's hand fly up into the air. Okay, is the microphone working, Bill?
I believe so.
Mike, are we ready? Yes.
Hi there, this is Ryan calling from the Renal Clinic. Is this a good time to chat for a minute?
Hey, Ryan. Yes, this time works.
Great, thanks. Am I speaking with Jonathan Anderson?
Yes, you are.
Thanks, Jonathan. I'm calling about your follow-up with Dr. Smith that was set for next Thursday at 1 p.m. We need to reschedule due to a conflict on Dr. Smith's end. I've got a few options. Would you prefer something earlier that same day or a different day next week?
Could we look a few weeks out, preferably something in the afternoon? My mornings are typically pretty chaotic.
Absolutely, we can look a bit farther out in the afternoons. Here are some afternoon slots with Dr. Smith. Monday, November 10th at 12:30 p.m. or 4:30 p.m. Thursday, November 13th at 9:30 a.m. morning, so likely not ideal. Friday, November 14th at 11 a.m. late morning. Monday, November 17th at 1:30 p.m. Tuesday. November 18th at 2:30 p.m. Wednesday. November 19th at 3 p.m. Thursday. November 20th at 3:30 p.m. Friday, November 21st at 4:30 p.m. Monday, November 24th at 4:30 p.m. Wednesday, November 26th at 11 a.m. late morning, Thursday, November 27th at 12:30 p.m. Friday, November 28th at 2 p.m. Do any of those afternoon times work for you, or should we look at early December as well?
Thank you, Ryan. That's quite the availability. I appreciate the in-depth detail. How about the 17th, please?
You got it. Monday the 17th works. The slot I have that afternoon is 1:30 to 2 o'clock. Does that time suit you?
Could we push it back by 30 minutes?
I don't have a 2 p.m. slot on Monday the 17th. Dr. Smith's only opening that afternoon is 1:30 to 2 o'clock. If you'd like something a bit later, Tuesday the 18th at 2:30 p.m. is available. Would that work?
Yes, please. Let's switch to that date.
Perfect. Tuesday the 18th at 2:30 p.m. it is. I'll note that as your new follow-up with Dr. Smith. Would you like a reminder sent by text or email?
Yes, can you send it to my email, please?
Absolutely. I'll note your preference for an email reminder for Tuesday the 18th at 2:30 p.m. with Dr. Smith. What's the best email address to use?
jonathan.anderson123@gmail.com.
Thanks, Jonathan. Just to confirm, is that jonathan.anderson123@gmail.com?
Yes, that's correct.
Great. I've got you down for Tuesday the 18th at 2:30 p.m. with Dr. Smith, and we'll send the reminder to jonathan.anderson123@gmail.com. Anything else I can help you with today?
That's all. Thank you, Ryan. You've been great.
You're very welcome, Jonathan. Thanks for your time today. We'll see you on Tuesday the 18th at 2:30 p.m. Have a great rest of your day.
All right. Thank you so much, Bill. Thank you so much, Bill, really. Okay, this was all that we wanted to show on AI voice agents. So thank you. I'm going to leave it over to Hanjie.
Thank you so much, Karin. Do you like it? I hope it's fun, yeah. I will then talk about generative AI in healthcare, how it's transforming the clinical practice. So before I talk about generative AI, I want to briefly recap on what is traditional AI. So I think most of you know what is traditional AI? So it normally takes the structured data. So for example, from electronic health record, like patient demographics, treatment information, lab information. It can also from dialysis machine, from medical images, from the data from wearable devices. And all this structured data will be fed into AI ML, and it mainly performs 3 kinds of tasks: diagnosis, prognosis, and treatment recommendations. This is the common traditional AI. And then we talk about generative AI. Generative AI is normally trained on unstructured data. It can be anything from online, any books, any papers, anyone posts something. And then the main output is generate new content. It has different types of generative AI. It can be text-based, image-based, audio, video, or mixed information. So for today, we're mainly going to talk about text-based. So this is the one you commonly heard, large language models, LM. And you may also heard LM normally works on predicting next word. And then if we, let's say, imagine if you can predicting the next word, what would be the most intriguing thing you want to do? Okay, so here is a novel. It was a dark and stormy night, and things going on, and therefore, the murder was, imagine right now, you need to predict this next word, and the LM is going to capture all the information, all the clues, the relationship between the people mentioned, and then come out who is the murderer. And this actually sounds like, I mean, you may know this person, one of the world's best detective, sounds like the way how they analyze the context, how they come out to the next word. But now let's look at how actually LM do it. So in order for us to know that, I want to briefly mention attention mechanism. This is the most fundamental thing about large language models, how it could work. In 2017, there is a paper called Attention is All You Need come out. This is probably the most important paper over the last 10 years. In this paper, it laid out this architecture called transformer, and inside there is multi-head attention on both sides, you can see here. So attention, what it's about? I want to give everyone very high level and visual to explain what is attention mechanism. So imagine this word, this sentence, a fluffy blue creature roamed the verdant forest. So every single word has its own meaning. Fluffy, blue creature, their own meaning. But what the attention works on is find the relationship among this word, try to update the information of the word. So now, the creature is not a regular creature anymore. It's a blue, fluffy creature. The meaning of the word need to be updated to know the context. And same is for the forest. Now I will give you an example for the medical field, like related to dialysis. Let's see this sentence. The pressure dropped after your filtration rate is increased. If people work here, you will know what this pressure means. Because all this blue word dropped filtration rate, it's related to this word pressure. And then the meaning of the pressure, this means blood pressure. And the same for AM. It knows this is blood pressure, not other pressure. And then another example, the pressure increased in the arterial line. Because the relationship of the increase and the arterial line, this pressure means arterial pressure. This needs to be captured by the meaning of the word. So then it will understand the whole context. Then follow on, it will know what you are talking about. Then you can really make the better prediction for the next word. Okay, so this is the background on the LM. Then what is about in the healthcare? So it can do many things. So first, it can enhance clinical efficiency and documentation. It automates routine administration tasks, allow more quality time with the patient and interaction. So you may all heard about ambient AI scribe right now. So there is many online, like on the market, this kind of tools. It can listen in to the conversation between the physicians and the patient and transcribe the information in real time. And end of the conversation, you will get detailed note, summary, and even into the structured format for you. So this really helps reduce administrative burden and professional burnout. It can also help with documentation. Right now, the GenTI works much better than the traditional OCR. It can extract any information from any kind of document, no matter PDF, handwritten, or any format, to a structured way. So this really helps the documentation efficiency. It can accelerate medical research, driving transformative intervention in every dimension of diagnosis and therapeutics. So normally when you do research, the first thing you do is to ask a medical question. And then you may have heard of this tool called Open Evidence. It launched from Mayo Clinic. Actually, we have 2 persons from Mayo Clinic today. This is an amazing tool. You can ask any medical information. It will give you the detailed response with all the references listed below. So this is the first step we always do whenever we do any research. It can also help patient screening. I think Dr. Blood is here actually in the audience today. So this is the research his team was working on and published in JAMA this year. So they compared using menu with AI-assisted pre-screening for trial eligibility using LM. And you can see clearly the AI will speed up the patient enrollment. It can also generate unlimited medical images with very high resolution and be used to develop the diagnostic tools based on these images. It can also predict protein structure. So for here, the gray is the ground truth and the blue is the protein structure. So the large language models can also predicting the structure and also predicting the interactions between the protein and antibody and glucose here. What else the GenTI can do? It can personalize care and education. It personalizes the patient education and care plans and support clinical training for clinicians. So here I'm going to just talk about one example. Actually, we developed in Renal Research Institute. We call it Ask Google. It is AI assistant tool, so you can ask any information about hemodiafiltration user guide and overview handbook. It's developed by medical office. And then, so for example, here, if you ask a question, how to achieve optimal outcome, it will give you the response, give you the page numbers, give you the reference link to the PubMed. So all this information are exactly coming from the handbook and the papers we selected. And this is only a screenshot, but if you are really in the tool, if you click on the page, you will be able to see the page show up on the left side. You can side and side compare the information is correct and relevant based on the original source. We talk about all the amazing things which LM can do, but I will come to the hallucination, which I'm not going to do an example today because I think all of you know people talk about hallucination all the time. I want to talk about why large language model hallucinate. There is many reasons why it would hallucinate. I want to highlight maybe 2 key reasons. So one of the main reasons is actually related to the system design, how it's trained and evaluated. So currently, the standard training and evaluation procedure, they reward guessing over acknowledging uncertainty. So you may see a lot of scoreboard like this. They rank all the models on the market, okay, who get 90% accuracy on which test and the other tests. So this kind of scoreboard really make the companies compete on the accuracy rather than, sometimes they have to acknowledge uncertain. It's the same as all of us. When we do a test, when we have multiple choice, A, B, C, D, everyone will select one, no matter you know it or not, because 25% chance you will get it correct. Sometimes if you rule out of 1 or 2, you get 50% of a chance. You will always go for a choice. The same for AM. They will always go for something because they know they will have a probability to get it correct. If they do nothing, that will be 0. This is the fundamental reason right now, the reward-related issue to the hallucination. Of course, there is another major reason, is with the data. So I want to show you some examples to give you a visual understanding how data leading to the hallucination and the bias. So let's say if I ask, this is on ChatGPT number 5 right now, 5 version. So I say draw 10 clock, 10, 10. And you see it draws 10, 12 clock actually, but it's 10, 10. It looks perfectly, although I know it's 12, but every clock is 10, 10. It sounds amazing. Oh, AM knows how to do this. Sounds really nice. But if I ask again, I say draw 2 clock with time, 1:35. It still do 10 and 10. And then so, oh, maybe I'm asking too much. Let me do 1. I said, okay, draw 1 clock, 1:25. It still do this. And then the reason why is that. If right now anyone can go to Google, if you search clock, just word clock, you see majority of the clock images online is at 10, 10. The reason is people saying, if the clock display at 10, 10 is the most beauty. I don't know why, but that is the reason why it was showing online. So this is the data and the fundamentally leading to why they are doing this. I will give you another example. Draw a person writing left hand. It's actually doing in right hand. And you see where I'm going. If you do online right now in Google, if you search person writing, this is what you're going to get. Majority will be the person writing in the right hand. Now I want to come back actually to this one. So why do you think it do 12, not 10? I ask for 10, but it do 12. I have a hypothesis. I don't know, everyone, what do you think? So my hypothesis is, if you look at majority of the drawing online, or like anyone's beauty standard, symmetry is the beauty standard. If someone's face are most symmetric, they're the most pretty person in the world. It's the same for a lot of drawings. So when I am doing this, it cannot lay out 10 in a rectangle perfectly. Then it decides to do 12 instead of 10 because it wants to make it look better. I think I finished on the hallucination part. There is one thing about AM I know a lot of people didn't talk about, but there's also a lot of research on it. It's about overconfidence. I guess you may all experience they have the overconfidence. And so this is the 3 models evaluation. So normally if you as a human, your confidence relates to how much you know the material. If you know you can get it correctly, you are more confident. If you give you something you never know, you feel really uncomfortable to answer. But this is different with the IM. So even when they're at very low accuracy level, they still perform very confident, particularly ChatGPT-4, or like any ChatGPT model. They're normally very confident on what they're going to say. And another thing I really want to highlight in this figure, so the color representing the difficulty level. So the green is high school, and orange is college, and the red is expert. Then you will notice, actually, it didn't matter the difficulty level. The accuracy actually are similar. They can do really, really amazing things on the expert level, but they can still fail at very, very simple tasks. And I guess you may also experience that. It can be really amazing, the same time can be really bad. And it's the same one. Yeah. And then this actually reminded me one of the things, I don't know how many people know this. It's not related to AI at all. It's purely human survey during pandemic. Pandemic, the kids are at home, they will do homeschooling. There was a survey published in New York Times. It said, I will read it out. Nearly half of the men say they do most of the homeschooling. Only 3% women agree. This is totally human. then this, because when I remember this, I thought like, what do you think this is? This is hallucination or this is overconfidence? And you see like where LM got all these things. It's really follow the human characteristics along the way during the training because it's trained on the human material. So we talk about all these things, then how about the consideration in applications? I know there is many consideration we need to worry about for the applications. But I think there is two major things. So first is data privacy and security. So when AM gets better and better, the same is for cyber attack. Cyber attack getting much, much better right now. So this is definitely fundamental before we do any application. We need to make sure the patient information is private and is secure. And then the other thing is human oversight is essential. So AM can be really amazing at a lot of things, but we can never replace the professional judgment. So if you check any information generated by AM, really should have the professional to double check if the result was reasonable. Okay, I think this is my last slide. So what is your next step then in the AI-enhanced healthcare? Start today. Explore AI tools to see how can you use it to change your practice to deliver better patient care. I think then I will pass to Karin. She will do a few hands-on examples. Thank you.
Okay, we have 17 minutes to go of this demo. And we were thinking to do some hands-on trials of large language models. Anyone who has a smartphone is encouraged to participate. And we encourage you to maybe try a new LLM, one that you have not used before. So these barcodes go to ChatGPT, Gemini, or Claude. However, I recommend Claude requires login, so it takes a while to set it up. But if you haven't tried Gemini before, give it a go. The way how this is going to work is that I am going to put on clinical scenarios on the screens and also prompt, which is the text that you would send to the large language models. But you know, writing the text takes a lot of time. So for this demo, we figured it's easier that you just take a photo of what is shown on the screen and send that to the large language model. For those who haven't communicated with photos before, if you press the tiny plus sign, Gemini looks pretty much the same. A camera or upload files option will pop up. And from there, you can send the picture to the LLM. If you are using especially Gemini, and you ask it to make plots, to create figures for you, sometimes, for some reason, it says that it is not able to generate or display graphical images. If this happens, Gemini just need a little human pep talk. Generate the plot, I know you can do it. And then, in 98% of cases, the plot will show up. Okay? Let's give it a go. So, pick a model of your choosing. And then the first case that we are going to take care of is every single clinician has gotten one of these from a patient. You have asked your patient to measure the blood pressure at home, and you get one of these crinkly handwritten notes that has been in a pocket. There are coffee stains on it. And I figured we could try some LLMs to make sense of this. So the first thing I want you to do is take a picture of this. Do not send it. Just take the picture and upload it to the LLM. I hope you now have a photo of this note. And then I want you to take a photo of the text. You can, of course, write it as well. Help me analyze this note. First, list all blood pressures. Take a photo and send it off to the LLM, and let's see what we get. I have, of course, also done this. Let me see. And when I'm running this with Gemini, I am successfully able to translate from this crinkly note into the actual blood pressures. Are you happy with the outcomes?
I am happy with the outcomes.
Yeah? Anyone else got correct results? I see Annabelle. Yes, David, everyone, visit. Yep, we're good. Let's move on. Stay in the same conversation with the LLM, because we are going to ask more questions about this note. Please, take a photo of this text and send it. I want a figure, a plot, showing how pressures change over time. And remember, you might need to give a little motivational speech to the LLM if it doesn't do what you want it to do. Any results yet? Is anyone able to generate the plot? Annabelle is nodding. Yeah, see some Stefano's hand? Yeah? Visit, does it look correct? Looks good? It looks great. Is anyone getting unexpected results? Are we ready to move on to the next prompt? Yeah? The patient started antihypertensive medication on the 6th of October. Mark that in the plot. Does it look correct, Annabelle? Okay, let's go on to the next one then. What were the average pressures before and after introduction of the medication? Any outcomes? What does it show? 3.5. We are getting different numbers. Should we move on to the next prompt? This sounds like the first time we have started to get a little bit of different results, right? Next, I want to add these pre- and post-medication averages to the plot. Is there anyone whose plot does not look something like this? David, what does your plot look like? It doesn't make any sense. Completely different. All right. But yours did look good. Okay, so mixed results then. So with this case, we wanted to show how you can use ChatGPT or Gemini with, it seems like, varying performance. Let's conclude that. To go from a quickie note like this into some sort of graph that makes a little more sense. We have 6 minutes left, which is not a lot of time, but maybe we can run one of the remaining cases at least. I would like you to take a photo of this prompt. This is also going to be a plotting exercise where we are going to simulate how a patient's kidney function is changing over time. So we have a case here with a 30-year-old patient, and she has a perfect kidney function right now. Her eGFR is 100. And we want to plot out what the trajectory of her kidney function is going to be over the course of her lifespan. I hope some trajectories looking something like this in this ballpark are starting to show up. I see you're nodding, Jacob. Yeah? Did you get a similar result? Yeah? We're done? Ready to move on to the next one? Now, this would be the second prompt. Let's say this woman gets diabetes, engaging her kidneys at age 40. And I'm thinking this could be good for education, maybe not to the patient, but at least to students and coworkers. If, let's say, this diabetic kidney disease is well controlled and treated according to all protocols, what would the trajectory be? And compare that to if the diabetic kidney disease is not controlled. So here we are asking the LLM to not only decide what is well-controlled and not well-controlled trajectories, but also to plot this. So we can here see that The LLM has decided that a well-controlled diabetic kidney disease would decrease with about 1.5 units per year, compared to the natural aging, which would be 1 unit per year. And if the diabetic kidney disease is not well controlled, this patient would lose 4 milliliters per year. Did anyone get a plot like this? Yeah? I see some nodding heads. Good. Did anyone get very different values of decline compared to 1.5 and 4? Maggie, what did you get?
For well-controlled, I got 2, and not well-controlled, I got 6.
Okay, yeah. So it's a bit more, but not outrageous. The last prompt. If this patient could avoid diabetes for another 10 years, so instead of starting at 40, the diabetes would start at 50, what would the trajectory of the kidney function look like? This is the result that I got. How does it compare to what's showing up on your screens? Any results showing up yet? Not exactly the same. It does not show all of the lines. Yours is GPT-5, yeah?
We took it a step further and looked at GLP-1 use, and it actually took the data and showed an improvement in overall kidney function.
Okay. All right. Thank you so much for participating in this hands-on exercise. I would conclude that the performance has been a little bit of this and a little bit of that, but I think it is it's very cool how much these models can actually do today. And I think given the this crazy train that AI is on, and the performance just getting better and better exponentially pretty much by every 6 months, I think if we would redone this trial in a year from now, hopefully we would all get positive results, and results as we are expecting. Okay, thank you so much.